Welcome back everyone to another video here on the Unknown Code YouTube channel. We are working on LeetCode problem 66 plus 1. This problem states you're given a large integer represented in inside of an integer array called digits, where each digit I is equal to the ith digit of that integer. So basically they're going to give us a large number broken up inside of an array. The digits are ordered from most significant to least significant, left to right. The large integer does not contain any leading zeros. This again is pretty important because we know that we're not going to have any random zeros on the left side where they're not supposed to be. No big deal there. What we're attempting to do is increment the large integer by 1 and then return that resulting array of digits. So we can't just add 1 and return it. We need to go ahead and actually modify all of the elements inside the array that we need to in place and then return that modified array. This one we don't have to do in place because it's actually kind of impossible whenever we add new items. So we'll figure out how to do that. But let's go ahead and take a look at a couple of examples they give us. So for our first example, they're going to give us an array called digits with 1, 2, 3. So our goal here is to add 1 and then return that. So the integer will be equal to 123. If we add 1 to that, that'll be 124. So the return or the output will be 1, 2, 4 inside of an array. Simple enough. Let's go ahead and take a look at the next example. The next example gives us an array called digits equal to 4, 3, 2, 1. Once again, this will be equal to an integer of 4,321. If we add 1 to that, it'll be 4,322. So the output array would be equal to 4, 3, 2, 2. Now these have all been very simple, straightforward ones. Let's take a look at the last example, which shows one of the complexities of this problem. In example number 3, we're just going to be given a digits array equal to 9. Now this is obviously going to equal the integer of 9. But whenever we add 1 to 9, this is going to create 2 digits now instead of 1, because it's going to equal to 10. So obviously now our output is going to be 2 indexes long instead of 1, and the output array will be 1, 0. Now this is going to be a problem that we have to actually think about as we're moving forward here. Okay, now let's go ahead and hop back up, take a look at constraints, see if we can get anything else, and then move on to the next steps. So for the most part, the constraints are pretty simple. The first one just says 1 is less than equal to digits.length is less than equal to 100. So this just means that the digits array is between 1 and 100 items. Nothing too crazy there. If we needed to brute force it with a double, for loop, whatever, it would still pass. Obviously, it wouldn't be the fastest. The next one states 0 is less than or equal to digits of I is less than or equal to 9. So this one's pretty important because they're not going to slip in any double digit numbers or anything inside any of the indexes. We're only going to be working with single digits. However, it could technically be 9 as we can see. As we saw earlier, if it is 9, it's going to have to create some carry and things like that we'll talk about in a little bit. So that will be a little bit of a challenge, but we can get to that. And finally, it says digits does not contain any leading zeros. Again, this just means that on the left side of the array, there's not going to be any zeros. So don't have to worry about carrying anything over like that. It also means that it's not going to help us out any. So if we do need to make a bigger array because we carried a 1 all the way over to the left side, we are going to have to make that array ourselves. There's no free space for us to add that in. So just kind of keep that in mind as well. So once again, the goal here is that we want to add 1 to the final index of the array and then cascade any needed changes all the way up to the array until we've determined that final integer. To solve this problem, we can simply loop through the array starting at the end. If the value at the current index is less than 9, we don't have to do anything to carry the digits. This means that we can just add 1 there and then return the array. But if we have values that are equal to 9, then we need to continue carrying that remainder over until the loop is either complete or we hit another number that's not equal to 9. So let's go ahead and take a look at the pseudocode and the example walkthrough before hopping onto LeetCode. What we're going to go ahead and do for our pseudocode, we're going to go ahead and start out by saying for each element in digits, we're going to say while the current element is 9, then we're going to go ahead and set that current element to 0. Otherwise, we're just going to set the current value to current plus 1 and go ahead and return that digits array. If we made it all the way through the loop, that means we haven't returned anything and that we have 1 carryover at the end. So we're going to say if not returned. Then we need to go ahead and make a new array that is 1 index larger. We're going to go ahead and set that first index to 1 and go ahead and return that new array. So that's how we're going to set that up. Let's go ahead and take a look at our example. For this example, I kind of set up a custom one. So we're going to have a digits equal to 15399. So we're going to start at the end. So I equal to 4. Our digits of 4 is equal to 9. So this means we want to go ahead and set digits of I equal to 0 because we added 1 to it and then continue. For I equal to 3, our digits of 3 is equal to 9 again. So once again, we'll set digits of I equal to 0 and we'll continue. For I equal to 2, now our digits of 2 is equal to 3. So now we just go ahead and say digits of I is equal to digits of I plus plus. And then we want to go ahead and return digits. And digits will equal to 15400, which is correct. We added 1 to the value. So that looks good. Let's go ahead and hop over to LeetCode and take a look at how we can program this. So inside +1, we're going to go ahead and start out the for loop for int I equal to digits.length minus 1. I is greater than or equal to 0, and I minus minus. Inside here, we're going to say if digits of I is equal to 9. Then we want to go ahead and say digits of I is equal to 0, just like our pseudocode. Otherwise, we want to say digits of I plus plus and return digits. This basically means that we have found the solution already because there's no other 9s. We can just go ahead and set that next value and return it. But if we make it all the way through the for loop, we want to go ahead and say a new int array called result. This is going to equal to a new integer array, the size of digits.length plus 1. And what we want to go ahead and do is say result of 0 equal to 1. We want to say return result and go ahead and submit. Fingers crossed, no typos again. And as we can see, we have a 0 millisecond runtime, which will beat 100%. It also beats 82%, which is strange because I literally just accepted this 3 minutes ago and it said it only beat 20%. So I don't believe their numbers on memory efficiency whatsoever. But anyway, hope you all enjoyed. If you did get some value out of this, please make sure to leave a like, comment, subscribe. Anything helps out the YouTube algorithm. As always, my name is Ethan or Unknown Coder. Hope you have a great day, and I'll see you on the next video.